Hello friends, today I am going to discuss descriptive statistics. So let's see, in this video I will discuss what is the mean, median and mode. These are the descriptive statistics, and we will also try to discuss variance, standard deviations. So let's see, first, what is the mean? Mean is the average of a set of values. So if I want to get a mean, so mean will equal to sum of the observations divided by the number of the observations. It's a mean, just I have already written. So it's a mean should be like a sum of the observations. So should I write like a xi and by it's a n. There are two types of the mean. One is the simple mean, another is like a population mean. So if the simple mean, we can assume like this, so x will equal to x1 to xn and divide by the n. And population mean we can intimate like this, so we can start like this, it's a xn and it's a divided by the capital N. Let's try how do we get the mean, and next will be discuss like a weightage mean. Weightage mean will equal to like a x1 w1 plus x2 w2 and plus xn wn whole divided by w1 plus w2 plus w until wn. So let's see discuss with the how to calculate mean in a Python. So I will create a sum value. Look here, I have already created. So it's a find a mean here. So let's see the sample. I have created 1 3 2 5 7 0 2 3, and we are going to find mean. So the sum of sample as a variable and divided by the length of the sample. So let's see, just it's run, and I have gotten 2.875. it's a mean. So you can see all polled 8 people on the number of the you can say the pets they own. The sum of the sample is a 23, and it should be divided by 1 2 3 4 5 6 7 8. So we have gotten like a 2.875. so number of the items in the sample is 8. There are two versions of the mean we have already. One is the x mean, another is like a one is the sample mean, another is the population mean, and just I have theoretically I have discussed. And third mean likely weightage mean. Weightage mean means actually is the weightage average, you can say. The mean commonly used gives the equal importance of to each value. So weightage mean, how do we calculate in the Python? So weightage mean will equal to, I have taken a sample like a 80, 90, 80, 63 and 87, and weightage like a 20% of the 90 and 20% from a 80 and 63% from a 20, and it's a 40% from 87. So weightage mean weightage underscore mean should be equal to the sum S will multiplied with the W, and for SW in a zip like a sample weight divided by the sum of the weights. Let's say we have gotten 18 point. Let's see, this is called a weightage mean. So this can be helpful when we want some value to contribute to the mean more than others. So the common example of this is the weightage like as a academic exam to give a final grade. So if you have a three exams and the final exam, and we give each of the three exams like a 20% weight and the final exam like a 40% weight. So how we express it is in this. So this is the example we can understand. So in the first examinations we have gotten the 20%, second exam we have gotten 20, and third is also it's the final examinations we have gotten the 40%. So our overall we can say the score is this. So it's a very easy and the basics, so I don't think you will get a difficult. Similarly, just we have also calculate like a weightage mean in Python is the other way. So there are like three exams like a 20% weights in the each, and the final exam we have got in the 40%, like 90, 80, 63, 67. So we can write the weightage like a 1, 1, 1 and 2.0, and we can do the same value. Let's see the median. Median is the middlemost value. What is the median? So median we can see the it's a middlemost value. So it's a median is the middlemost value in the set of order value, because ascending and descending is the most important. So in a set of order values. So if we have like a 20, 10, 30, 40, first we need to the arrange in ascending order. So let's, what is the lowest value? It's a 10, then 20, it's a 30, and then 40. Then we will divide in the two parts. Is it this value is the odd and even number? So n should be like a 1, 2, 3, it's a 4, so it's a even. So how do we get the median? So we have a simple data, so it's a, so we will use like a, and if n is a odd we can use like a n plus 1 by tooth observations, and then we can get, but here is the even. So n, so median will equal to n by tooth observations plus n by 2 plus 1th observations divided by 2. So it's a 4 means second observations, and plus it's a second means third observations, and it's a divided by 2. So we can say the second and third like a 20 plus 30 and divided by 2, it should be like a 50 by 2 means 25 is your like a median. So it's a very simple, it's a not a more difficult, but let's see how do we solve. So it's a calculate the median in Python. So let's go ahead. It's a calculate median. So first I will create a like a sample. It's a sample should be create a list and some value like you can start from like a 0 comma 1 comma 5 comma 7 it's a comma 9 comma 10 which we can take one more value like a 14. So let's say 1 2 3 4 5 6 7. So 7 we can understand like it's a odd value. Now let's define here. So we will apply here in Python like a def median. We have create your own functions and it's a values as a parameter. It's a values. So we are going to define median and order like a first we will already discuss we need to the order. So the order should be equal to sorted sorted and it's a parenthesis put here the values. Now the print order. First we have to the print order. It's a print order. And after that just we have already printed like your order. Then we will describe like what is the n. So n should be equal to length len inside of this parenthesis ordered. And then mid mid should equal to integer int and n divided by 2 so minus if n uh, n write in and it should put here the percentage symbol like a modulus. Okay, minus it should be n by 2 minus 1. Then if n percentage 2 should be equal to 0 and else integer must be like a n divided by 2. It's right. But n if now let's go ahead. So we will if n percentage 2 should be again equal to 0 and return order like a mid and it's a plus ordered mid plus 1 ordered mid plus 1 and whole should be divided by like 2.0. Then we will use here else, and it's else should be go here because it's a front of the end. Yeah. Now the else return ordered, it's a ordered, and we can write here like a mid because I am getting a mid value, so return a mid and print the median sample. And let's see, just go back, let's print parenthesis median, and inside of this parenthesis what's a variable, it is simple, let's check it. So yes, I have gotten like this. It's a like integers shouldn't be equal to, and def functions if and else I have done print. So median can be a helpful like a attractive to the mean. So when the data is skewed by outliers, the value that is the extremely large and small compared to the rest of the value. But let's see what happened. Yeah, it's a median. Look here, it's a 7. We have gotten the median. It's a this value only. So we can edit all these value, and I think it's a 7 should be the median. So it's a very easy and the simple. So first we have already added 0, 1, 5, 7, 9, 10, 14, and then after that we have gotten median. So it's a very simple. So median is also like a quartile. So there is a concept of the quartile is the descriptive statistics learning. This means the concept of quartile is essentially the same as median, just cutting the data the other places besides the middle. So the middle is the actually 50% quartile. The value where the 50% ordered value are behind it. So there are 25%, 50%, 75% quartile, which are known as the quartile because they cuts the data 25% increment. So let's the after that I am going to describe like a mode. What is the mode? Mode means the most frequently occurred sets of value. So mode, first I will try to erase. So let's the mode. Mode is the most frequently most occurring set of values. So it primarily becomes useful when your data is repetitive and you want to find which value occur the most frequently. So when number of values occur the more than once, there is a no mode. When two values occurs and equal amounts of frequency, then data set is the considered bimodes, and calculate here the mode like calculating the mode in a Python. So let's go. Let's go here. Write here the mode. and from we need to the some library like a prompt collection, prompts collections, import a for de fau lte lt default. Let's check it. Yeah, it has been imported. Then we can create the sample. So let's say sample just I have already created. So let's say list 1 comma 3 comma 2 comma 5 comma 7 0 comma 2 comma 3. It's right. But now I want to describe this samples. So let's the diff as a function, and we are going to create a mode function. So mode and right here the values. So we have created like the own functions, and we will count like a count is it's a variable. So count should be like a we have created d for a default dict, and we will use a lambda function. So it's a default dict lambda, it's a lambda lambda, and it should be equal to like a 0. And then we will use here like a for loop. It's a for s in values like this, and counts like a s, and we can put like equal to 1. And then we will create one more like a max underscore count. Go back. So I will start here, go in front of, it's a max underscore count has been created like a max. So we are talking maximum counting value, maximum times we have counted value like counts dot values and parentheses. Then we write create the mode should be equal to create a list, and we can write we have created v for v insert. What is the sets? It's the values. If count v values, if count like a v it should be equal to max counts. It's a max underscore max count. Now return modes. So modes and print mode simple. Print mode simple. It's right. So I think I have gotten some errors like this. Okay, counts the modes. Count should be maximum count is right, and then it should be okay. We write the modes, then we have repeated. Modes should be equal to modes will equal to v for v insert values if put here like a counts max. Yeah, let's see here 2 and 3. So we have gotten here like a 2 and because 2 is the twice and 3 is also twice. So in particularly mode is not used the lot unless your data is repetitive. So this is commonly encountered with integers categories other discrete variable. So it's a basic idea. So when we start like talking about like a variance and standard deviations, it's a really interesting, but on this the confuse people with the variance and the standard deviations is there are the some calculation differences for the sample versus the populations. Populations variance and standard deviations means describing a data. We are often interested in measuring the difference between the mean and every data point. This gives us a sense of how spread out the data is. So let's say I am interested in studying the number of pets owned by a number by my work staffs, and I have 7 people in my staff. So it's my population. So it's I take the mean of all the numbers of pets they own, and I get some mean, and let's just subtract the mean from a value. This will show us how far each value is from the mean. I assume the number of the pets my staffs own. So it's a one way we will try to understand. So similarly we can write here like a population variance like this. Okay, so if we are talking about like a variance, so populations variance should be x1 minus mean equal to x2 minus mean equal to xn minus mean and divided by n, right? Similarly, we can write here xi minus square divided by n. So calculating the population variance, take example in the Python. So let's try here like this. So we have a similar data we will collect here. So go here, this data should be like this. I have like this. So let's see. We are going to calculate here variance, and just let's write here the sample like a data you write here, otherwise you can change the name. It's a data variable, and then we can define like a diff as a diff variance. Variance should be values. Variance should be the values we have created like a own values. Then we will need to get a mean. So mean should be like a mean will equal to sum of this data. So sum of values we have taken a VALUES and divide by the length of these values. So LEN and values, and now the variance should be, so now let's go ahead. So underscore variance, let's write underscore VARIANC, it should be equal to sum, and we have taken like a V minus mean square, so it's a square for V in values, V in for V in values, and should be divided by LEN values return variance. Now return underscore variance, then we will go the print variance like a data. So let's see, I think it's a should go back, I think what, okay, don't worry, we have gotten the some error like a RETURN and it's not a, it's a return underscore variance. It's give it some space. It's right. Yeah, just I have gotten a variance like a 21. So the variance for a number of pets owned by my office staffs is 21.387755. But what does it exactly mean? It's a reasonable to conclude that higher variance means more spread. But how do we relate this back in our data? So this number is a larger than any of our observations because we did a lot squaring and summing, putting it on entirely different metric. So how we squeeze it back down, so it's a back on the scale and it's started like this. Just I have already discussed with the formula. So we can reuse the variance functions and square of this result. So this is called a square of this variance is called a standard deviations. So we will get a standard deviations as it is the same data. So we can write and we will get a standard deviations. So standard deviations should be equal to like this. So how do we write here? So let's see here. It's a standard deviations. It's a like s square should be sigma xi minus x mean whole square and it's divided by the n minus 1. So like the variance and standard deviations for a population, it's a population, so there is the important we need to apply these two formula. It's a variance and it's a population like a standard deviations, like you can write sigma xi minus x mean whole square and it's divided by the n minus 1 inside of square root. So it's a basic way we can calculate the standard deviations for a samples and like a for a populations. So I hope it's a we will try to understand. So next time we will describe like how to get this standard deviations and I also try to the like describe the normal distributions. Thank you for today.